All right. So coming back to the discussions that we were having, concept wise, once you understand, it's nothing. It's quite simple. But yeah, the terminologies has been made a little bit complicated. And what we are trying to do essentially is the replacement study. The key question is whether you want to replace a particular equipment within this year or not, right? That's the question that you ask. So we have seen some of these. I'll not go into detail, but the idea is there's a defender and a challenger. Challenger is the new alternative, defender is the typically the existing alternative. You do the analysis of annual worth values. That's what the method specifies, and you do the analysis on per year. What does it mean? We will look into examples. You basically do the analysis today. You make a decision whether to keep the challenger or defender for next year. Do the analysis again next year. If the values have changed, the answers may change. If the values have not changed, the answer may remain same, but you have to keep on doing it, right? And then this concept of economic service life is something that I had started to discuss, which is, I was mentioning that it is different from the actual service life of a equipment, and this is also different from the service life that you have used in your depreciation studies. Okay, depreciation studies, service life is just an accounting term that could or could not be related to the actual performance of the system in the real world. Actual service life is okay, beyond which you cannot reliably use a particular piece of equipment or a machinery. It could even cause a safety hazard and things like that. But then there is a concept of economic service life, and which is essentially that ideally you should operate or use a particular equipment only till the time where its costs are minimized. The moment its cost starts increasing, you should ideally not use it. So why it starts increasing and all is something that I will show you today. But that's the main concept, that typically the total cost of any asset will follow a curve like this. So you should only use the asset till the operating cost for it becomes lowest value. Beyond that, you should not use it, ideally. That's the economic service life concept. In replacement, we are doing the economic service life concept. Again, there could be assets which are useful beyond your economic service life. They might be costly to operate, but they might be also useful for you, because sometimes finding the alternative may not be easy. So it could still serve because they are properly functioning assets. Okay? All right. So yeah, a lot of these ideas, I'll not go again, we have already covered. There's something called an idea of defender first cost and the challenger first cost. Typically, the replacement analysis is done on the defender's first cost, which is equal to its current market value. Doesn't matter what has happened with this particular defender in the past, how much money did you pay to acquire a particular defender. All it matters that you are doing the analysis now and you will use its current market value. If you were to sell this today, what will be the value that you get is something that you have to consider in defender's first cost. And then challenger's first cost is, of course, it's a new product you are going to buy. So of course that's cost, but sometime there could be also a trade-in kind of an example that I got, that because you are choosing to replace the defender with a new challenger, there could be some additional value premium people will be willing to pay. That also considers into account. And then also defender's first cost, in case your challenger is, for example, a really new technology, that the performance level of the challenger and defender are significantly different. In that case, you may need to make some gadgets or add some functionality to your existing defender, and cost of doing so should also be taken into account, so that you're comparing both on the equal terms. So the assumption is always your defender and your challenger have equal capabilities in terms of their functionality. Okay, again, we have covered this in detail. I'll not go into all this today, but please read through these slides, otherwise you'll not be able to get what I'm talking about. Okay, all right. So this is the concept that I was finally referring to in the last classes, the concepts of economic service life. All right. So the economic service life is defined as the number of years n at which the equivalent annual worth of cost is the minimum. Okay. Considering the most current cost estimates over all possible years during which the assets may need to provide. So, because you are doing the replacement analysis again and again and again, or for making sure that you always have the latest projections of all these cost numbers, in that you choose the value of economic service life such that the annual worth of all cost is minimum at that service life for whatever the value you have chosen. Okay. How do you calculate it? I am going to explain you. So, it essentially represents the estimated life of an asset, and that life should be used in engineering economy studies. If n years have passed, the ESL indicates that asset should be replaced to minimize the overall cost. So, that's the idea. Beyond n, beyond the economic service life, you should not be ideally using the machine because it is costlier than it is for using it till the nth time. Okay. So, in the replacement study, you are expected to determine the economic service life of both the defender as well as the challenger. Alright. And how it is determined is, you basically there is no quick function. Essentially, you assume, let's say n is 1. If n is 1, what is the annual worth of all the cost? You calculate. Now you assume n equals to 2. Accordingly, that you can calculate the annual worth. If n equals to 3, you can calculate the AW, so on and so forth. You choose the value of n such that you obtain the minimum annual worth of the total cost. Okay, I'll show you the example. So, the total annual worth have been or can be actually represented. You can see any general cash flow series that we have seen previously. These are annual operating costs, right? This minus P distributed over the entire and the S distributed over the entire series. We have seen this term before. What it is called? Capital recovery factor, right? This is the amount that asset needs to at least generate in order to make this overall series a profitable one, right? So, the annual cost, the total annual worth of all the cost is essentially your capital recovery factor, if you take the cost as a out, and the annual worth of actual operating costs, right? In the previous cases, what we saw that annual operating costs we were defining as equal, but it could be non-equal as well. And in reality, it will be non-equal because as the machine grows older, you can expect that it would demand more and more maintenance charges and operating costs and so on and so forth, right? That's precisely that you have a trend of total cost like this, that the annual worth of only the operating cost keeps on increasing as the number of n increases, because in general that's the expectation, and when the number goes high, the capital recovery factor goes down, because then you are distributing the same cost over larger number of periods. So, the total cost, which is the sum of the capital recovery plus the annual, will have a profile, typical profile like this with the minima, and that minima is the economic service life. Okay, graphically shown here. Let me show you how to actually calculate it. You can try to memorize this formula, but essentially nothing. It's just a simple capital recovery, which is the P value distributed over the whatever n you assumed, S distributed using A by F formula over the entire n periods, if you are assuming that n is the economic service life, and then the total cost, annual operating cost till that period is the annual operating cost in an nth year or a jth year, which is again distributed using P by F formula, first taken to the future worth and then distributed back on the annual worth, right? A by either you P by F, so you are bringing it to the present worth and you are distributing back to the equivalent annual series. Why am I doing this? If AOC are not equal, then you need to do this. If it is equal, then ultimately this series will simple be a sum of A. right? Then you don't need to worry about this transformation. But since the annual operating cost in each year could be different, you need to first convert them to the present worth and then redistribute it over the entire series. Understood this calculation? Let me give you an example, will make it more clear. Okay. So, a small manufacturing asset which is 3 years old is being considered for an early replacement. Its current market value is 65,000 rupees. Estimated future market values and annual operating cost for the next 5 years are given below. Okay. In this table, I am giving you the values of future values. What will be the market value of this particular asset in future, 5 years from now on, 1 year from now on, 2 years from now on, and what are the corresponding operation cost in each year that it will require, right? What is the economic service life of this Defender if the interest rate is 10% per year? Okay, this is the question. So, what you do is, simple formula, we first assume that your economic service life is 1 year, you calculate corresponding to 1 year, you move to the 2 year, you calculate corresponding to 2 year, you plot the trend and choose the minimum point. Okay, so for 1 year, what is the total AW, total annual equivalent cost is this 65,000 initial value distributed using A by P formula over 1 year period, because that's what I'm assuming, that it is a 1 year equivalent, plus the 45,000, because at the end of year 1 the market value of this asset is 45,000, so that becomes the salvage value for me, right? Because I'll be able to sell this machine at 45,000 after year 1, 45,000, that A by F factor, 10% for year 1, right, minus the annual operating cost. Since we are talking only about 1 year, that becomes 12,500. Okay, you do this calculation, it is coming out to be 39,000. Clear? Any confusion here? No? Okay. Now, assume n equals to 2 or economic service life equals to 2 year. So, the original value of 65,000, instead of getting distributed only for 1 year, now it gets distributed for 2 periods. The salvage value at the end of year 2 is available from this table, which is the market value, estimated market value of this asset after 2 years has been given to you. That becomes 40,000 distributed on 2 years, right? Now, each of these terms, the annual operating cost will have to be distributed over the entire 2-year period. So, how do you do that? You first bring the present worth kind of a formula. This is happening on 1 year, this is happening on 2nd year, and this entire series gets distributed using A by P formula for 2 years. Is it making sense? The cash flow series is essentially this is S, this is P, this is your AOC 1, this is your AOC 2. Got the idea? I brought this to present worth, I brought this to present worth, redistributed the whole thing to 2 years. You could have brought this to here, redistributed using A by F formula, doesn't matter, answer would be same. Okay, with me? Are you able to understand how the calculation is proceeding? So, in this case, the total AW, if it is assumed that N, the ESL is 2 years, comes out to be 31,380. Okay? N equals to 3. The series becomes right, 65,000 A by P distributed over 3 years, 30,000 is the market value, which is your expected salvage value at the end of 3 years, That formula comes here. The first period, the annual operating cost is 12,500. The second is 13,500. The third is 15,000, distributed to present worth with respect to the number of years, and the entire series distributed over the whole equivalent annual using the A by P formula. Clear? If you do this calculation, it is coming out to be minus 30,661. Okay? Can you do n equals to 4? Okay, do the calculation for 4 years. You are essentially solving for this cash flow series. What is the first cost of the Defender? How much is it? What is the value of P? 65,000? Something else? 65,000. What is the value of S? 10,000. These have to be distributed for 4 years and 4 years. Rest of the problem is clear. Tell me the answer. Minus 32,700 and this is your option 1. 32,781. Okay. Anyone in 33 range? 35,476. Option D. 32,676. Okay. And option E. Nobody with option E? Okay. So your answer is 32,781.13. These are fine. What's happening with C and D? D also still I can understand, maybe you did not take couple of decimal points, but C, yeah, concept wise remains same. 65,000 distributed for 4 years, 10,000 distributed for 4 years, year 1 AOC, year 2 AOC, year 3 AOC and year 4 AOC combined, brought to the P by F, distributed using A by P for 4 years. If you do the calculation, this comes out to be 32,781. We see that cost is starting to increase, right? Compared to the n equals to 3, it's starting to increase. And then finally, when you do the calculation again for n equals to 5, you will get an answer like 32,899. So, since at year 3, you are getting the minimum total annual worth, so that is considered your economic service life. The trend here is somewhere like this. But this is a very real, very ideal case, just to make sure that you understand the concept. You might even have, because of you may not be able to estimate all of these things, you may not find some functions which will be having a minima, or you might have functions which are like this. In that case, you just need to, there will always be a information for you to make sense of what is the kind of time horizon you are dealing with. For example, in this case, if it is only 1, 2, 3 periods you are dealing with, then you have to choose the minimum of them. But it could be possible that you are dealing with a time horizon of 10 years. In that case, you may need to plot it again and you will have that ESL will be coming somewhere else. But this kind of information will be there in the questions for you to make some inference of where to stop doing this calculation. Okay? Conceptually, fine? Alright. So, Now, what values to use actually for replacement analysis? So when the latest estimates on the market values for each of the subsequent years are available, you can estimate the economic service life as I just showed you, and then annual worth at the ESL number of years is used for comparison for defender and challenger. Okay, it could be possible that the defender's ESL is different compared to challenger's ESL. The values that you're comparing is the annual worth for each of the defender and challenger for their respective ESL lives. That is the number that you're comparing to make a judgment whether you will replace or not. Okay, I'll show you again. But in case there is any change in the market value of any of these parameters, you basically need to do the calculations again and then make a realistic estimate. Therefore, this is a method which is only applied on a yearly to yearly basis, because it is extremely dependent upon the current market value estimates that you have. So you do not have applied method for directly for 2 years and 3 years and things like that. You always make a yearly comparison. Okay. Alright. Now there could be two cases in where you need to perform the replacement study. One is there is no clear indication of what the study period horizon is, versus there is a clear indication of what the study period that you are looking for, right? The concept of study period is clear to all of you. It's the planning horizon kind of a concept that you, no matter what happens, you are only worried about 3 years, 4 years, doesn't matter what the economic service life of each of these alternatives are, as compared to in the first case, you will do the study on based on the economic service life that you will estimate for each of the challenger and defender, right? I'll go through that in detail. But the idea is you need to yearly on yearly, you do the calculation for the defender's ESL and the challenger's ESL respectively. How do we do? This English is what you do, which is essentially very simple, but let me first explain to you and then it will all make sense. Okay, read English with me. Alright, here's step 1. Determine the annual worth. Small c is the essentially depicting this annual worth at NC number of years. NC is the economic service life of the challenger. So determine the AWC and AWD values using the estimates of challenger and defender respectively. Imagine the number of questions in a single question. You are first estimating ESL for each of the alternative. Then on that you need to do the calculation. So all the concepts that we learned are becoming tiny when you actually make the decisions. So you need to ramp up your process of calculations as well, right? Now, based on the better of the AWC and AWD value, you can select either the challenger or defender, one with the lowest cost you need to select. When the challenger is selected, replace the defender now and keep the challenger for next NC number of years, which is its economic service life. This replacement study is complete. Step 1 over. Essentially you are doing an estimates of both the ESLs. You estimate both their total annual worth for each of these ESLs. You compare the numbers. If you find the challenger's AW is better compared to the defender, you immediately replace, and then this replacement is done, because once you have replaced, this defender is gone out of the question. So you need to keep using this equipment at least for the next NC number of years, which is the economic service life of the challenger. Make sense? Logical? If the defender is selected, plan to retain it up to ND more year. Ideally, you need to do this estimate for that same logic. If you are selecting challenger for NC years, you need to select defender for ND more years. But you do the analysis next year again, because typically the defender's technology becomes obsolete very quickly. So all these market values and everything will change very rapidly. So therefore, even if you decide to use the Defender now, you need to do the study again. And if the values have changed, then you need to do the analysis again. Okay, so far with me? Alright. So this is Challenger Alternative C, AWC for NCS, AWD for NDS. That's being the calculation at this present time. Step 2. After 1 year, suppose you select Defender. After 1 year, look at the estimates, especially the first cost, the market value and AOC of both the Challenger and the Defender. Okay, the challenge has not yet finished. Still, the Challenger is there to challenge the position of the Defender. So, if these estimates are not current estimate, you need to estimate them again. Step 3 is essentially estimate them again. However, if the estimates are current estimates and this is year ND, suppose you have reached, the estimates have not changed, but you have reached year ND. So, beyond that, anyhow doesn't make sense to keep the Defender, because from now onwards, Defender will start costing more. So, you replace the Defender with the alternative. So, essentially you are reaching the end of economic service life of the Defender, and therefore you are again calling that this is a end of this replacement study. We know when exactly the replacement will happen, right? If this is not year ND, retain the Defender for another year and repeat the analysis, right? So, the idea is, suppose ND is 3 years. I do the analysis today. Today I found that my ND is better, my Defender is better, so I keep it, I am not replacing it. I go to the year 2, again I do the analysis. If I find that my Defender is still better, I am okay, I am not replacing. If I find Defender is no longer better based on the realistic estimate, I replace it. Now year 3, doesn't matter what happens, because I know that this is the optimal service life of this equipment, I am going to replace it, doesn't matter what the AWC or AWD comparison says. And then, since you have made a decision to replace in year 3, essentially this replacement study is done. Got the idea? First case was relatively simple. If at the first instance you find that Challenger is to be replaced, then you just replace it in the current period and then use it for the next NC number of years, unless they start giving you more information that the current Challenger is going to be challenged by something else and all. If you want to make your life complicated, you can always have that. But real world is that complicated because technology is always evolving. So these kind of things do happen on a daily, very frequent basis. Okay. Step 3 is nothing. Essentially, I have written this English so that I could teach a computer program to do it, but you are human, so you don't need all these step 1, 2, 3. But just in case you are confused, just look at it. Step 3 is, whenever the estimates have changed, update the system, update all the calculation and determine new AWC, AWD value and then do the analysis again, right? Okay. So 2 years ago, Toshiba Electronics made a $15 million investment in a new assembly line machinery. It purchased approximately 200 units at $70,000 each and placed them in plants in 10 different countries. Okay, the equipment sorts, tests and performs insertion, order, kitting on electronic component in preparation for special purpose circuit boards. I like these details to just confuse. There is basically no relevance. But this year, new international industry standards will require a $16,000 retrofit on each unit. Because you are dealing with consumer electronics, there are always a quality control and safety issue. If the quality of the consumer electronics is not good, your devices might burst, your batteries might backfire, and you don't want them. So essentially, they have to upgrade their sorting process to quality control. That's the kind of they need. So originally they bought it at 70,000. In order to keep on using, because the regulation have changed, they need to put $16,000 additionally to make the functional requirements met, right? In addition to the expected operating cost. So this 16,000 is in addition to what the already operating cost is going to be, right? Due to the new standards, coupled with rapidly changing technology, a new system is challenging the retention for these 2-year-old machines. New regulation, new technology, you have to make a decision whether you want to keep using or replace it with a new one, right? The chief engineer of Toshiba USA realizes that economics must be considered. So he has asked that a replacement study be performed this year and each year in the future if needed to. The I is 10% and the estimates have been given below. Your estimates are for Challenger, the first cost is 50,000. Future market value decreasing by 20% each year. Estimated retention period no more than 10 years for Challenger. AOC estimates $5,000 in year 1 with increase of $2,000 per year thereafter. Okay, this is all Challenger related information. Defender related information. Current international market value $15,000. You bought this machine 2 years ago at $70,000. Current market value only 15,000. Future market value decreases 20% per year. Estimated retention period no more than 3 more years. AOC estimate $4,000 next year, increasing by $4,000 per year thereafter, plus the $16,000 retrofit that you will require immediately in the next year. Okay? Lots of info, but hope you are able to detect what you will need to calculate the main thing. Okay? Oh, the solution is even more terrifying. The question, bear with me. There was another example that was very simple that I had kept in my original slides, but it was such a terrible example that it really did not serve the purpose. You still have doubts. So just this morning I have put this new example. Again from the book, the same book that we are referring. So if you are not able to understand here, you can always refer to the book, but I'll explain it better, that I can guarantee. Okay. So the question A, B, I am also telling you that there will be a question C on the same premise. Okay. Question A. Determine the AW values and economic service lives necessary to perform the replacement study. And a related question is perform the replacement study now. Right. Anyhow, like in order to solve question B, you were required to solve question A first. So this Excel sheet essentially gives you the ESL analysis for Challenger as well as the ESL analysis of Defender. This formula, right now I am not 100% sure what is happening. So do not blindly trust this, but when you read the book example, you might try and it will give you some answer. But right now I do not blindly trust it. I will still show you the calculation from our regular method that we have done. Okay. Okay, let's start putting the values. I is 10%, common for both. If you are talking about the Challenger's first cost, this is what? 50,000. Market value is given decreasing 20% per year, and you are given an information that you cannot use it for more than 10 years. So the maximum life that you are looking at is 10 years for the Challenger, right? So the market value, you can plot 50,000 10%. How much is it? No, 50,000 20% decrease. So the remaining 80% is what? 40,000. 20% of 80% of 40,000, 32,000. 80% of 22,000 to 56. You can go and plot for 10 years. This series making sense? Okay. The AOC, $5,000 in year 1, increasing by $2,000 every year, right? $5,000 in year 1, increasing by $2,000 every year. Make sense? Capital recovery factor, you can estimate. How will you estimate? For year 1, the capital recovery factor would be what? Minus 50,000 P by A, no, A by P, 10%, 1, plus the salvage value at the end of year 1, which is the market value at the end of year 1, which is 40,000. Which formula? A by A by F 10% 1. Calculate this value. This should be 1.1 and this should be, I think, 1. But give me the answer. $15,000. So it's essentially minus 50,000 multiplied by 1.1 plus 40,000 multiplied by 1. So it's coming out to be minus 15,000. Right? Matches the capital recovery factor here. Here they have done some PMT calculation. I am not able to still understand what's happening. So you have the formula, try it out. We'll find the logic later, but I didn't have the time in the morning. Essentially the same calculation that we have seen so far, right? So the annual worth is of AOC doesn't change because you are dealing with year 1. Same calculation that we have done. The total AW cost for year 1 becomes 20,000. Okay, same calculation that we have done. Year 2, your P will still be 50,000. Salvage value will become what? 32,000. You're distributing everything on 2 years. Your AOCs will also have slightly different. You first bring them to present worth, distribute back to the 2 years. Same calculation. You will see the total AW of the cost will come out to be minus 19,000. Okay. Good enough? Essentially, you then plot this curve, assuming in first case ESL is just 1 year, second case you are assuming ESL is for 2 years and so on and so forth. You find out that ESL is minimum somewhere at year 4, or this AW of cost is minimum somewhere at the year 4, right? Now ESL analysis for Defender. Your current market value is not 70,000. It is, doesn't matter what happened to the equipment in the past, is not your concern. You are only worried about what is happening right now. 15,000 decreasing 20% each year, right? In the first year, the AOC is 4,000 plus 16,000 that will be required for retrofitting. Make sense? Do the same calculation. You will find the ESL for this will come out to be 3 years, because beyond that the information says clearly that you do not want the beyond 3 years. Right? There was a method somewhere. Yeah, estimated retention period no more than 3 more years. So you are not going on n equals to 4. There is an information given in the question about what is the maximum range which you are looking to keep this equipment. Beyond that, you are anyhow like, okay, this is useless, not going to use. So n equals to 3 in this case. Okay. Similarly, information was also available for the first part of the question. Make sense? So then all this is how you will actually supposed to solve your questions. You can actually make this formula once automated. You can easily do this calculation, not a problem. Right? You don't have to necessarily rely on a direct formula. This is pretty easy to calculate even in a normal Excel sheet. All you need to know is which dimensions to consider and so on and so forth. Right? Okay. So based on this, your AWC value is 19,000 and your NC is 4 years. Your AWD value is 17,000 and your ND value is 3 years. So this year, what is your decision? Retain, because your total cost of Defender are lower than the Challenger. So this year at least you retain. Move to step 2. Because you retained, you need to do the calculation again and again, and that's also expected in such kind of a tricky situation because technology is rapidly changing and your existing equipment is deteriorating faster. So you need to do that calculation again. This is the answer to your the replacement study now. For next year, new market information has come. So your problems are not solved yet. The part C of the question is, after 1 year, new estimates have become available for a lot of things. So then you need to use that latest information in order to solve the problem. I'll just introduce this new information and then perhaps we'll wrap it up. So after 1 year, it is time to perform the follow-up analysis. The challenger is making large inroads to the market for electronic components assembly equipment, especially with the new international standard feature built in, because challenger has already complied with the new international standard, so it's rapidly everywhere. The expected market value of Defender is still 12,000 this year, but it is expected to drop virtually to nothing in the future, which is 2,000 next year, and the worldwide market and the zero after that. So originally it was slightly 12,000, 9,600 and 7,680, but now you estimate that the values are depleting much faster. Still 12,000, but then 2,000 and then zero immediately, right? Also, the prematurely outdated equipment is more costly to keep service, so the estimated AOC next year has been increased from 8,000 to 12,000 and 16,000 2 years out. Perform the follow-up replacement study. Okay, so this is where we will close the class. Okay, let me just, it's okay, it's too much to process right now. We'll start from this example tomorrow.